In this video, we're going to be talking about multiple regression from the perspective of a person who wants to use regression for modeling purposes as opposed to just doing prediction. Now, if you remember, when we were using multiple regression for prediction, you end up with your B weights and your beta weights. What you're trying to do is to get the best prediction you can, so you end up with a string of variables, some of which are significant, some of which are not. Those variables, those individual independent variables, may in fact share variance with other variables. For example, socioeconomic status and education, they're not the same thing, but they share variance. Well, we don't care about that when we're doing prediction. When we're doing modeling, we care very much about it. It's a very different thing. Then what we're trying to find out is we don't want to predict a y from a bunch of x's. What we're trying to do instead is to understand the process by which those x's create the y, if you want to look at it. We're trying to understand the underlying processes. So now what regression will do, if we go stepwise, for instance, it will pull out the x variable that has the largest beta weight, but then it will redo the entire regression. What you will often see then, that the order of importance that you saw, or the order of the beta weights that you saw in a prediction situation, it completely reorganizes itself. Because when you take out the variable, the x variable that has the largest beta weight, it may share variance, it may share causality with another variable, but now when we're modeling, that variance, that causality is extracted. So it is not rare that if you went through the prediction process and ordered the x variables from most important to least important by their beta weight, now when you're doing stepwise regression, they may come out in a completely different way, because you are removing that shared variance. And what you're trying to do then is to build a conceptual model of the relationship between those x and those y variables. So they're very different processes, and you start modeling in stepwise regression, you start from the perspective of, I'm not trying to predict a y from these x, I'm trying to understand the process. So let's look at some output, and we'll get a feel for how you would interpret a modeling regression.
So first we're going to look at these variables here. We have burnout is what we're predicting from these characteristics of counselors. These are pastoral counselors. We're trying to predict pastoral burnout because it's a big problem. So let's go to regression. And we're going to do linear regression. And we're going to pull burnout as our dependent variable. And then each of these other variables is on our independent variable list. I'm pulling them over one at a time just to make it clear. And in this case, we're going to go to stepwise. And let's get R squared change, because that will help us to understand the variance that's associated with each new variable. Here we go. And let's look at the output from that. There you go. Scrolling down a little bit. There were 4 solutions. Most important was anxiety. Then you see the second, third, and fourth variables. But the most important factor is clearly number 1. That has the largest beta weight associated with it. Look at the variables underneath it. They're very small. They're relatively inconsequential. Certainly by the time you get to the last one. That's not so important down there. What's really important up here is factor number 1. Anxiety is by far the most important factor.